National 5, you join me in Queen's Park on my evening dog walk looking across to the city of Glasgow. Now these lights are very apt for today's lesson because we're talking about resistors today, and all of these lights will be using some form of resistors in order to light up our city. Now I just want to show you something. Okay, this is the dark park. Alright, a bit of the sun just still there, but we also have the light of the city here. Alright, so one little analogy I want to make is that prelims are coming, exams are coming, times of darkness I guess for some of us, but as we go from that moment of studying and prelims, we will get to the moment of light, okay, beyond the prelims. But hopefully this channel will help you in your National 5 Physics to get the best mark possible. So National 5, hope you enjoyed today's lesson, and I'm going to pass back to the classroom. Just another day in the office, National 5. Hope you liked my little encouragement in Queen's Park. Why am I holding 2 plants? I'll tell you why I'm holding 2 plants. Because they're dying. And I would love if anyone could give me advice on how to keep these guys alive. I've got a rose bush which is dying, and I've got a spider plant that's floppy. I'm a physicist. I'm not a biologist. I don't know what I'm doing. So anyone who is listening or who's watching, save me. Save these guys, and I will give you a shout out. Alright? Comment below. Now, as you can see, 222, we are growing and growing and growing. But National 5, I've got a new message for you today. The new challenge is 300. 300, and I know you're getting tired, but we need to have a second win because 300 subscribers by the February weekend. So we've got Christmas, we've got January, New Year's resolution, subscribe to Mr. Bull's Physics. There we go. Get your friends to subscribe. 300 by February weekend. That is the new challenge, National 5. That is the new challenge. And I'm going to start a wee hashtag. I'm going to start a wee movement, and that movement is Physics is Family. Physics is family. Okay, we are the family of physics, of Mr. Bull's Physics. Hashtag Physics is Family. Comment below as well. You've got lots of commenting to do, National 5, so get commenting below. And a shout out to the National 5s in my 4th year classes who have gone a little bit quiet. I see you, National 5, I see you, and you know who you are, you're gone quiet. I need you to lift the life up again. Come on, raise the roof. This is National 5, this is for you guys. I want to hear you and I want to see the comments below from my National 5 classes. Come on, this is for you, alright? So my shout out is for you guys today, alright? Anyway, right, on to the physics I imagine, alright? Electricity resistor problems. Now we're going to very briefly talk about resistors today in series and in parallel, and we're going to do some example problems, okay? So, we know that when we have 2 resistors in series, we very easily just add them up, okay? So resistors in series is super easy. We just add them up. So that was 10, that was 10. We would add them up, 20, okay? Series circuits are super easy when it comes to resistors. Now, we also know the voltage in a resistor splits, so it needs to get up to supply voltage. That's what we learned 2 weeks ago, okay? So this voltage, say this was 10 volts, say this was 10 ohms and 10 ohms, and that was 6 volts, that would split evenly, 3 volts and 3 volts, okay? So, that's fairly straightforward. What happens when we talk about parallel circuits? Now, parallel circuits are very interesting because the resistance in a parallel circuit is defined as 1 over RT, which is total, RT is total, equals 1 over R1 plus 1 over R2 plus 1 over R3. In fact, if you add all these resistors together in this format, you'll get a total value less than the smallest resistor. Less than the smallest resistor. So you're actually decreasing resistance when you put the resistors in parallel. We know the voltage stays the same in each one, but we know the current splits. So the resistance is smaller than the smallest resistor in the parallel branch. Okay? Now, another thing to note is that if every single one of these is the same, so 10 ohms, 10 ohms is a bit hard to do it, 15, 15 and 15 ohms, what we can do is we can actually find out the resistance really easily. It's just going to be 15 divided by 3, which is 5, okay? Or 15 if it was 2 divided by 2, which is 7.5. So you can actually do that nice easy way, but that's not often asked, okay? So normally they're different resistances. So what we're going to do is we're going to jump into a whole bunch of examples and hopefully help you guys understand all the questions that could be asked, okay? So let's jump in. Now, example 1, and I'm going to try and do this on here. Let's do this. Brilliant. Okay. So, for example 1, 3 resistors of 100 ohms, 200 ohms, and 500 ohms are connected in parallel. Calculate the total resistance of the resistors. So, 1 over RT, 1 over R1, plus 1 over R2, plus 1 over R3. So 1 divided by 100, just put the numbers in, over 200 plus 1 over 500. Okay, and what we end up getting, okay, is a number, okay, when we do RT of 58.8 ohms. Now, can I just go through a wee step here that I didn't do, alright, that I didn't do. So I've jumped the gun here, okay, so you can't just go from this to this, right, but I want to show you something. So if I was to take a step out of here, okay, and what I'm going to do is I'm just going to get my calculator, because I have written down the answer without actually giving you the in-between step. So, 1 divided by 100, okay, plus 1 divided by 200, plus 1 divided by 500. So what I actually got was, in this bit, 0.017. And to get 58.8, what I do is to get 1 over RT, I flip it, so RT comes at the top, and then 1's at the bottom, but that means I'm going to do 1 divided by that. Okay, so 1 divided by 0.017 gives me 58.8 ohms. Okay, so that was the intermediate step. I wanted to make sure you get that. Okay, another way of doing that is in your calculators there's always a wee button. I might even just lift up here. There's a wee button that looks like that there with a wee -1. If you click that, you will get your answer that you need, and it should be a fairly decent answer. 58.8 is less than the 100, which is the lowest resistor. Okay, right. Let's go to the next one, and to do that I am going to need to go over here. I apologise, National 5, and there we go. Okay, I might just have to use this here. So, yes. Now, for this one here, we have a parallel circuit with a bulb in series at the bottom and a bulb in parallel combining both the branches. Okay? So, with this one comes a whole bunch of other examples that we need to work through. Okay? So what we're going to do is going to do another example looking at something that looks like this. Okay? Right. So this one here says calculate the total resistance of the circuit below. Okay? So to do this, okay, I am going to, oh, there we go. Perfect, wonderful, it's working. Right, so to do this, first of all, you have to find out the resistance of the series branch first, okay? So we know that that here is 12 ohms, okay? And we also know it's parallel to the 4. So what we're going to do is we are going to then just do our 1 over RT equals 1 over R1 plus 1 over R2. Okay? Now, we know that 1 over 4 plus the total of the series, which is 1 over 12. Okay? So for that one, we get 1 over 3. And then remember, we flip it with that method I showed you. So RT is actually going to be 3 ohms, because that's just going to be other way around. Alright? 3 ohms. So it's actually not too bad a question. Now, for the next one, when I calculate the total resistance of this circuit, we see that we're not in a parallel circuit, we're in a series circuit with a little parallel bit put in. So for this one, we are going to find the parallel circuit there, and then we're going to add it, because it's a series circuit, to the 400. Okay? So, to do this, we're going to do 1 over RT equals 1 over R1 plus 1 over R2. And the R1 is 100, and the R2 is 200. Alright? We get that, we get 3 over 200, and when we flip it round, x to the -1 in your calculator, we end up getting, I think it's 58.8 no, 67 ohms. But the total resistance is 67 ohms plus 400 ohms. So the total is going to be 467 ohms. Alright? Because we're adding 400 to the total of that. Okay? Right. Last one. Alright? This one is a nice series circuit, but we're going to have to find out the voltage, okay, and the current of this resistor. So the first one says calculate the current of the 60 ohm resistor. We just do the same again. Alright? We know the total resistance is 40 plus 60 because it's a series circuit. So that's 100 ohms. So to get the current, I equals V over R. 5 divided by 100 gives us 0.05 amps. Alright, so that's the current going through the circuit. Now, for this one, calculate the voltage. Okay, so we've found out the current. What's now the voltage of the 60 ohm resistor? Okay, so V equals IR, 0.05 times the resistance, which is 60, which gives us 3 volts. Alright, so if that's 3 volts, that should be 2, because then we get 5. Alright, National 5? So that's a bunch of examples based on resistors. And we've used the two equations, RT equals R1 plus R2, and 1 over RT equals 1 over R1 plus 1 over R2, depending on how many resistors there are. Okay? And we've also seen that there's V equals IR questions in there as well. Alright? So, go through those again, step-by-step process. Go back to that first one where I went through the wee gap and showed you the calculator, okay? Make sure you understand that because those questions come up a lot in National 5 prelims and exams. Alright, National 5, that's all for me this week. Alright, let's see if we've got anything else except see you guys next week. Alright, see you guys later.